All right, now we're going to consider blood type. Recall that blood type is a trait that's controlled by multiple alleles. So there are three alleles we need to consider here. Two dominant alleles, capital I with a superscript A, and capital I with a superscript B. These are for type A and type B blood types. Now, there are two ways that you can have type A. You can be homozygous for type A, or you can be heterozygous, which means that we have the A allele, and the second allele is our recessive allele. This little I, if we have a homozygous recessive, you end up with type O blood. It's recessive to all other blood types. Likewise, for type B, there are two ways to be type B blood. You can be homozygous with the type B allele, or you can have one of the type B alleles and then the recessive I allele. This is for blood type, and this would give rise to type B blood. The first example would give rise to type A. Now there's a fourth blood type because neither A or B alleles are dominant over one another. So if both alleles are present, if I have one copy of the A allele and one copy of the B allele, I end up with my fourth blood type, which is type AB. The rarest blood type is type O because it's that double recessive allele. So now let's take a look at what this looks like in a problem. Blood typing can be useful in solving paternity cases. Although it's somewhat restrictive, it can point us in the right direction. In this situation here, in this first problem, this is sample problem 1, we have a man who's type O, and he marries a woman whose type is AB. We need to determine what the blood type of their children are. Well, the only possible blood type and the only possible allele combination for type O blood is the double recessive little I, little I. Likewise, the only possible combination for type AB blood is one of each of the alleles. Now we know that during meiosis and the principle of segregation, the two copies of the allele get separated, so that during fertilization, the one copy that's present in the sperm and the one copy that's present in the egg come back together. If I were to divide up the man's two alleles, I would get little I or little I for sperm. And if I were to divide up to the woman's, I would get a choice of either a capital, the dominant A allele or the dominant B allele. I want to figure out what their children look like, so I'm going to go ahead and put it in my Punnett square. Some of this has already been done for you right over here. Let's go ahead and solve. Go ahead and finish the square now as I work on it as well. Okay, let's see what these kids look like. Let's consider our first square here. We have the dominant A allele and the lowercase I allele. This blood type here is type A. This is repeated here, so this is type A as well. We have two identical blood types here. One of the dominant B alleles, and the other is the recessive I allele, so this is blood type B. Now let's look at our questions. Which percent of the offspring from this marriage are likely to be type A blood? Well, we can see that 2 out of the 4 squares have the type A, so it would be 2/4 or 50%. Letter B. What percent of offspring in this marriage are likely to be type B blood? We also have 2 out of 4 of our boxes are type B blood, or 50%. Question C asks, is it possible for this couple to have a child with type O blood? And we can see that it is not possible. No, it is not possible. Because in order to have type B blood, we would need the double recessive allele. So little I is the only genotype which gives rise to type O blood. So in order to be little I, both parents would have had to contribute a little I. we can see that that's not possible given their genotype. That's not possible given their genotype. So having a child with type O blood is simply not possible.